So, Life Cycles of British and Irish Butterflies, which also happens to be the title of a book that I authored, which came out in October last year. The purpose of this presentation is really to encourage viewers to take more of an interest in not just the adult butterflies, but their immature stages as well, which can be as fascinating and even more fascinating than the adult butterflies themselves. There are some terms I'm going to use as I go through the presentation. Each butterfly, each moth goes through 4 stages, which are egg, caterpillar, chrysalis, and adult. There are also various terms that tend to be used in place of those, so I'll tend to talk about larva rather than caterpillar, plural larvae, pupa, pupae for chrysalis, and I always use adult rather than imago. These 4 stages are illustrated by the Chequered Skipper life cycle that you can see on the right hand side there. A term that I use very frequently and will be using in this presentation is instar. And the best way to think about this is that an instar is a particular skin that the caterpillar is in. So the first instar is the first skin, second instar the second skin, and so on. And an instar really represents the period between molts. So when the caterpillar emerges from the egg, and before it molts for the first time, it's in its first instar. Between the first molt and second molt, it's in its second instar, and so on and so on, until the caterpillar ultimately sheds its skin for the last time to reveal the pupa. Anyway, so instar is, just think of it as a particular skin that the caterpillar's in. My own particular journey to maintaining this level of interest started from a very young age when I reared a garden tiger moth caterpillar to adulthood. I think I must have been about 7 or 8 years old. And more recently, I've took quite a serious interest in photography, which turned into an interest in ecology. And a lot of that is thanks to work, spending time with people like Matthew Boat, who you can see on the right-hand side here, who's taking a photo of an overwintering purple emperor larva. Um, and spending time with Matthew allowed me to, get photos of things like the purple emperor egg, as you can see in the top left there, with a fully formed larva inside it, and the newly emerged, newly hatched larva in the bottom left. Um, but spending time thinking about the ecology of what I was seeing took me much, much deeper into this fascinating hobby that we all share. And some of the things that I've encountered, I'm going to share with you as we go through the rest of this presentation. So, for my own particular studies, as well as spending time with Matthew on the Purple Emperor, I've probably spent the last 7 or 8 years focused on the White Admiral. So I'm very fortunate to live close to a well-known site for the White Admiral, Pamber Forest in Hampshire. And I personally think that the White Admiral is spectacular in all of its stages. So you can see a sort of hairy golf ball shaped egg in the top left, an incredible caterpillar in the top right, which has a characteristic pose. Looks like kind of an S shape when it's reared up like that. An amazing chrysalis. And the adult doesn't look that flashy from its upper side. It's just got white bars over very dark brown blackish wings, but the underside is incredibly beautiful. I'm so uh, in awe of this butterfly that that's the reason it's on the cover of the book. Yeah, simply because it's just amazing in all of its stages. Another species I've focused on in some detail is the Chequered Skipper. So in another presentation I uploaded this week, there's a little more detail in terms of that study. But I spent some time at Glasdrum Wood in northwest Scotland, near south of Fort William, where I studied the life cycle of the Chequered Skipper. So again, it's the best way I find of understanding a species is to actually spend a lot of time with it and try and cover every single stage. Um, so that essentially is, one of the things I did with both White Admiral and Chequered Skipper, but also spending time with Matthew on the Purple Emperor as well. So if we were to take things further and think about, other species as well and understanding their ecology, then there's always one work that I always refer back to, and that's Frederick Frohawk's incredible masterpiece, the 2-volume Natural History of British Butterflies, which describes in a lot of detail all of the species, and also includes very beautiful illustrations of each species as well. So some amazing plates also included in this work, which is one of my most treasured possessions, I have to admit. Now, one of the drawbacks of Frohawk's work is while the plates are beautiful, get a lot of enjoyment from just looking at the illustrations, to be honest. One of the drawbacks is that some elements of each species is very difficult to discern, especially because all of the larval instars are typically drawn life size. So if you were to pick on, in this case, a first instar Scotch Argus caterpillar, then it really is just illustrated as pretty much a brown blob, which is a little unkind, but it is pretty difficult to use this as any way of identifying something that you might find out in the field. In order to compensate for that, Frohawk has quite elaborate descriptions both of the behaviour and appearance of each larval instar especially. So for example here you can see it says the larva makes its exit by eating all round the crown and pushes up the lid and crawls out. And the subsequent paragraph is really describing what that first instar looks like. Now in this day and age, with the advances in photography and especially photography equipment, then I think we can do better. So for those two elements of behavior and appearance, we can create images that look like this. So this is a first instar Scotch Argus larva on the left, pushing its way out of its egg, pushing the lid that it forms away as it does so. And on the right hand side, this is what the caterpillar looks like once it's finally left the egg. So I thought to myself, could we actually do this for every single species and almost replicate what Frohawk has done using, modern day photographic techniques and what have you and equipment? So we conceived this project. I didn't actually name it. It was some collaborators on UK butterflies, but it became known as Frohawk 2.0. And I thought, well, is this actually feasible to do that kind of level of detail for every species? Because Frohawk work was a real inspiration in terms of really understanding the viability of doing this. So if one man could do this, admittedly it took him about 24 years to complete. But, with the army of photographers that we have and photos that are available, there is the potential to do something as comprehensive. So I had to think about this, and I thought, well, if we focus on the 59 species which are considered residents or regular migrants, for each of them we have 4 stages. So 59 times 4 is 236 subjects of interest that we need to focus on. And then if we also focus on every single larval instar, so every species generally goes through a fixed number of instars, then that results in 470 subjects of interest or thereabouts. So admittedly, that would seem, pretty scary as a figure. You just to take that at face value. But given that Frohawk had managed to do this, I thought, well, maybe we can. And that really spurred me on to thinking about, well, let's try and pull together a work that would essentially bring Frohawk up to date, both in terms of imagery, but also taking account of all of the things that we've discovered since his book was published. It actually came out in 1924, so quite a lot's happened in the last 90 or so years. So given the amount of effort involved in completing such a project, the obvious question to answer, and I must thank Richard Lewington for posing this really, is why? Why would you go and put all this effort in? What's the purpose? So one of the papers that really caught my eye, which helped me answer that question, is focused on the wall butterfly. So it's a paper written by Hans van Dijk and colleagues. Now it's important to know the wall brown can only successfully overwinter as a third instar larva. So in the north of its range, the butterfly goes through 2 complete broods, and then the third instar larva successfully overwinters. In the south of its range, it goes through 3 complete broods, and the third instar caterpillar successfully overwinters. But in the middle of its range, between north and south, there are populations where the butterfly goes through 2 complete broods, but a proportion of that second brood go on to adulthood, have to find a mate, lay eggs, and the caterpillar needs to get to the third brood in order for it to successfully overwinter. However, if none of those things are achieved, so they don't reach adulthood, don't find a mate, eggs aren't laid, caterpillar doesn't get to its third instar. If any of those things hold true, then the butterfly will essentially perish, and the result is a smaller population the following year. And this is a hypothesis for explaining why the wall brown has declined across some of its range. Um, but really to emphasize that my fascination with this paper is not so much the hypothesis itself, it's the fact that we need to identify a third instar wall brown caterpillar. So to take this point further, I attended the Butterfly Conservation Symposium, where I presented a poster session entitled Assisting Conservation Efforts Through an Improved Understanding of the Morphology of the Larval Instars of the Butterflies of Britain and Ireland. So I didn't win any prizes for the longest title, but what it did allow me to do was validate with the attendees that this was actually going to be a worthy pursuit, were we to pull together um, some material that would help aid the identification of the immature stages and larval instars in particular. And as it happens, the author of the paper, Hans van Dyck, was at the symposium, so I got him to autograph the poster itself before he left. So bit of fun there. So further validation came through working with Rachel Jones, who works for Butterfly Conservation, and she's studying the Lulworth skipper for her PhD thesis. And one of the things she was doing was also presenting at the symposium on her PhD. And I explained to her that if she ever needed any help with the identification of the larvae that she was searching for, just to let me know. So I actually pulled together the first description, the species description, which was of the Lulworth skipper, and I sent it over to Rachel, and she applied it in the field and was able to identify a first instar Lulworth skipper larva. She posted on Twitter here. So the larva itself is right at the bottom of the screenshot here. And what she was basing her identification on was this image, which I sent her as part of the species description that she was looking at. So again, this was further validation that this could help support conservation efforts. So being able to identify this both as a Lulworth, excuse me, both as a Lulworth skipper larva and as a first instar larva was helpful there. And things went a little bit further because Martin Warren was helping Rachel with her studies, and they were finding all sorts of larvae on all sorts of grasses. And Martin sent me several photos of larvae they'd found, and he was after my opinion. So what I pulled together was a table of each of the 4 species that they may have been encountering, so the Essex, small, Lulworth and large skippers, and the different larval instars, and essentially constructed this table which shows each of the instars of each of the species, so that would allow us to correlate the images. And it just so happens that most of these species have a primary larval pupal, which is different. So for Lulworth skipper, it's tall grass, but for Essex, it's cocksfoot. Small skipper, Yorkshire fog. Large skipper is also cocksfoot. But based on the images that Martin sent me, I was able to come up with my assertions as to what each of them might be, and Martin agreed once he'd received this table. So again, I thought this was we were coming, onto something in terms of helping field scientists identify the things that they were looking at, which is really the bedrock of any conservation efforts and habitat management and so on. So again, this was a final proof point that what we could potentially produce in terms of the book was going to be worthwhile. So full steam ahead. And then finally, once the book had come out, I just thought I'd insert this here. Many viewers will be familiar with the Chequered Skipper reintroduction program at Rockingham Forest in Northamptonshire, which is being led from the butterfly conservation side by Susanna O'Riordan. And Dan Hoare was in the field helping Susanna locate larvae as part of the reintroduction studies. And here he is holding a final checkered skipper larva up against the book, where there's an image of a final instar checkered skipper larva. So it wasn't really intended to be carried about in the field, but it was good to see that Dan was using the book to identify larvae. So the next question to answer, after you've decided that yes, this would be a valuable thing to do, is how would you actually do it? Because obviously there's many subjects of interest to be covered, and so on and so on. Well, first of all, there are certain tools which can help as part of the study itself. The ability to measure the length of a caterpillar as well as the size of something that's less variable, which is the size of the head capsule, is pretty important. For example, the length of the larva and the size of the head capsule can give a pretty good indication as to which instar the caterpillar is in. So here you can see a couple of tools, a vernier gauge and a micrometer for measuring length and head capsule size. And I can assure you that no caterpillars were harmed in the course of the study. But on occasion, these tools were pretty useful. In order to study some of the species, it was necessary to rear them through in captivity as part of this study. And before I embarked on that, one of the things I wanted to make sure was the ethical side of captive rearing was addressed. So I actually wrote an article, which is on the Dispal website, entitled An Introduction to Captive Rearing. And I also passed this by various amateur enthusiasts as well as some of the folks at Butterfly Conservation to get their approval that the approach to doing this was all above board and what have you. Many people ask me, well, how did you rear this species or that species? And well, some of the species were dealt with in the field for sure. But the most difficult, of course, was probably going to be the large blue, whose caterpillar lives in an ant's nest for the majority of its final instar. So, tackling the large blue. So thanks to David Simcox, who's the project manager of the Large Blue Reintroduction Programme, I was able to get a Natural England licence to allow me to rear through large blue larvae until their final instar, when they were taken back to the site from which the eggs came and released. So here you can see a picture of Harry, as he came to be known, who was the first larva to reach his final instar, after which all of the livestock I had was taken back to David and his assistant Sarah Meredith from Butterfly Conservation, and things returned back to the wild. So this is Harry after his final molt into the final instar. This is Jeremy Thomas, Dave Simcox, and Sarah Meredith collecting large blue eggs for a reintroduction program. This is Harry being attended by an ant just before his adoption, and seeing the adoption was amazing. I think after about 27 minutes of us watching Harry, he was finally adopted by an ant, and the grand finale was very rapid. The ant picked Harry up in its jaws and took it away to its ant's nest. But really, really an amazing sight to see. And because of their help, David and Sarah won the UK Butterflies award that year for their contribution to UK butterflies. So that's us at Daneway Banks in Gloucestershire. I thought I'd just show some amazing images leading up to probably the most incredible image I've seen of any immature stage of a butterfly anywhere. Just by telling you about the large blue itself. Some amazing images here, by the way, from Marcin Selesniuk, who's been studying the large blue in Poland. So essentially, once the larva has reached its final instar, it falls to the ground and it waits for an ant to come and find it. So when it is found, then the ant gives off secretions. I'll talk a little bit more about this later on. It gives off some secretions which are attractive to ants. So the ant essentially drums its antennae towards the rear end of the larva and obtains secretions from the larva. And at some point, and this is an incredible image as well from Jeremy Thomas, at a certain point the larva rears up on its claspers, the prolegs, and it mimics an ant grub in doing so. And the ant is clearly fooled into thinking that one of its larvae has somehow left the ant's nest, because what happens next is the ant will pick up the larva in its jaws and take it back to the nest where the larva feeds up. So here's some incredible images. Excuse me. So here's a final instar fully grown inside an ant nest after it's been feeding on the ant grubs. And as you can see, they're being attended by an ant still. And then this is the most amazing image I've seen. So this is a large blue final instar caterpillar eating an ant grub. So an incredible image there from Marcin. It's pretty gruesome, but amazing all the same. And then, of course, for the remainder of the life cycle in the ant nest, so the larva will ultimately pupate in the ant nest. You can see a couple of pupae on the left there, and on the right you can see a photo from Dave of a coloured up pupa where you can just make out the wing colouring inside the pupal case. And then, of course, the adult emerges, pumps its wings up, takes flight, and the life cycle starts all over again. But an amazing species, and it's a real privilege to be able to see the early instar larvae, and just experiencing that whole process all the way up to being adopted by an ant. Absolutely incredible. So that's essentially the end of part one, and in part two I thought I'd cover off topics I found particularly interesting in the course of writing the book. So we'll start with variation. So variation occurs in all of the immature stages as well as adult butterflies, and here are a couple of examples of eggs that have a variation in colour. On the left here you can see the egg of the orange tip, which is fairly white when first laid, but after a day or so turns orange, and it's thought that this is a mechanism to alert females to the presence of an egg so that they don't lay on the same plant. And this is especially important because the larvae are cannibalistic, especially in their early instars. And on the right here we have a similar colouring up of the egg of a dingy skipper, although the larvae aren't cannibalistic, so it's less clear as to why this colour change occurs. A theory is that it alerts the female to the presence of an egg so that the larvae don't outstrip the supply of food plants. So if there is more than one larva, then certainly on very small plants, then there's the potential for them to outstrip their food supply and ultimately perish. One of the other things that you see in terms of variation in egg colour is that the eggs of some species colour up in very unusual ways. So here's an example of one of the brown species, several of which have eggs that colour up in this way. So they may be a fairly plain colour when first laid, but they start to develop these reddish brown blotches after a few days and ultimately become slightly darker and more uniform as they mature and before the larva emerges. But again, it's important to understand that these changes occur if you're looking to identify eggs that you might find in the field. And of course, I say of course, it's not at all obvious, but there are also changes that occur within larval instars and within larvae more generally of a given species. So the example here is of a checkered skipper. So the photos on the left and hand side are both taken at Glasdrum Wood. The first one at the top during May, June when the adults are flying, and the one at the bottom probably around March, April, after winter, after the purple moorgrass, the larval food plant, has died back. And the amazing thing about the checkered skipper is that before it goes, before it basically overwinters, and when it's fully grown, you can see a very green caterpillar against a very green stem of purple moorgrass. But as you can see, the purple moorgrass dies off and becomes very straw coloured, and without feeding, so post-winter, after it's hibernated, when it emerges in the spring, the checkered skipper larva perfectly matches the colour of the purple moorgrass that has died back. So an amazing evolutionary phenomenon that we see here in terms of the change of the checkered skipper larva going from green to brown to match its food plant, as we see here. You may also see a variation within a larval instar simply because the instar is maturing. And here's a somewhat extreme example. So two images of a first instar comma caterpillar. The one on the left is newly emerged, and the one on the right is just about to change its skin into the second instar. So on the left, it's a fairly green, fairly plain colour, and on the right it's almost brown, and it appears to have these white blotches appearing on its surface. And the reason for that is that when it turns into the second instar, you can see that it does actually have white spines protruding from its body, and that is really a clue as to what you're seeing in the final stages of the first instar caterpillar. You may also see variation within a larval instar, in this example a holly blue, simply because it's changing colour as it prepares to ultimately pupate. So on the left hand side here you can see a fully grown caterpillar that's still feeding, in this case on ivy buds, and on the right hand side you can see a larva that is about to leave the plant and descend, possibly descend down the dark stems of the ivy to pupate under some surface. And of course it wants to match that surface as best it can. Hence it darkens in colour and becomes a dull purple. There are also different colour forms in larvae, in this case marbled whites. They happen to be nocturnal. As you can see, there's a photo of me taken by my friend Mark Colvin on the right there. But the marbled whites, like several other brown species of the browns, has two colour forms. On the left you can see the brown form, and on the right the green form. And again, it's important to know that these forms exist in order for you to be able to identify the species of larva and possibly the instar that you're looking at. And then finally, pupae also have different colour forms, in this case the black hairstreak. In all cases it's designed, obviously, I say obviously, but it's designed to mimic a bird dropping. And there's a brown form on the left and a black form on the right, as shown here. And another example, strangely enough, is in the wall brown. I say strangely enough because the wall brown feeds on grasses, and you think that the grass green form of pupa would be the only form that you would really expect to see in the wild. But occasionally the wall brown also produces very dark pupae, as you see on the right hand side. It's quite a rare occurrence, but the pupa is almost black, and nobody really knows as to why this form occurs. But it does occur, and absolutely fascinating. There's absolutely no difference in terms of the appearance of the adult that emerges from the pupa, whether it's green or almost black. So just another fascinating aspect of this particular species. And finally, there may be variation in the pupa simply because as it colours up, there may be differences because of the sex of the pupa, whether it's male or female. So here's an example of an Adonis blue that's recently formed, and if the pupa is going to turn into a female, then what you see coming through the wing cases is primarily brown colouring, because the female Adonis blue is normally primarily brown and has brown wings, whereas the male has a very fluorescent blue wing coloration, and so the pupa itself looks very different once it's coloured up from a female pupa in this particular case. In fact, when I first saw this male pupa formed in the Adonis blue, it was absolutely amazing because the electric blue that you see in the male butterfly also comes through in the pupal stage as well. An amazing sight to see. The next topic I found particularly interesting was some behaviours related to immature stages. One of those is the fact that certain species, such as the meadow brown shown on the left here and the gatekeeper on the right, they hang vertically downwards, head down, as do many species in the Nymphalidae. But in their cases, they don't attach their cremaster using hooks to a silk pad that's attached to a grass stem or what have you, but they remain attached to the old larval skin. So there are actually no hooks on the cremaster. So what they do is they somehow, through the magic of their morphology, attach themselves to the old larval skin, which is itself attached to a silk pad that is attached to the plant. So a bit convoluted, but very interesting nonetheless. This is actually one of the areas I'm looking to study further over the next few years. Another interesting behavioural characteristic is that having observed marsh fritillary and other species, that especially those that seem to lay their eggs in clusters, they always seem to pick on a relatively small subset of available plants. So when I was studying marsh fritillary at North Bull Island off the coast of Dublin, then I found this pair of females actually laying on the same leaf of the same plant of Devil's Bit scabious. And this was in an area about the size of a football pitch that was just covered in Devil's Bit scabious. So why did they both select the same plant? So, there are various theories as to why that may be. Some of it to do with microclimate, some of it to do with the suitability of the plants, and so on and so on. But again, this is something that I've seen repeated over and over again, whether it's small tortoiseshells, peacocks, Glanville fritillary, they always seem to select a small subset of available plants. And again, absolutely fascinating, worthy of more study for sure. And one other characteristic that's quite well known in terms of the Lycaenidae, the blues, the coppers and the hairstreaks, is their association with ants, which is known as Myrmecophily. And here we can see a silver-studded blue that's recently emerged and pumping its wings up. So you can see the ants crawling all over it because it emerges with some sweet droplets as it emerges from the pupal case that is attractive to ants. And on the right hand side you can see a Adonis blue caterpillar, which is also being attended by black ants in this case, and I'll explain why in a moment. And this is a silver-studded blue caterpillar that you can see on the left here, and on the right you can see a close-up of the rear end of the larva. There are actually three devices that the caterpillar uses to either attract or appease ants. First of all, there's something called porcupola, which are scattered all over the body, which give off a secretion. There is a honey gland, which you can just about make out on the right hand picture here. It's like a slit across one of the segments towards the rear end, and that gives off droplets of a very sugary substance, so it's packed full of amino acids which the ants find attractive. And the third device that you can see here is a tentacle organ. There's actually a pair of these devices at the rear end of the caterpillar. Only one of them is shown here. What they do is they tend to turn themselves inside out. It's known as an aversible organ, in turning itself inside out. And it's thought that this is a mechanism to provide a notification to an ant as to where the location of the honey gland is. So the caterpillar obviously gets a benefit in terms of the protection that the ants afford it from other bugs, and the ants get the secretions that are given off by the caterpillar in return. So in most cases this is a kind of symbiotic relationship. The next topic I found really interesting was parasitoids. So one of the most well-known parasitoids is this chap, Listrodomus nycthemerus, which is a parasite of the holly blue. So on the left-hand side here you can see a holly blue caterpillar, and on the right-hand side you can see the adult wasp. And essentially what happens is the female wasp lays its egg inside the caterpillar in one of its instars and develops as the caterpillar grows. And ultimately, after the caterpillar is pupated, then the wasp will cut a very neat hole around the pupal case and emerge, as you can see here. I'm probably one of the very few people who's tried to rear a holly blue larva through to adulthood, and being extremely happy when one of these wasps emerged, because it was the wasp I was actually trying to get a decent photo of, as you can see here. But absolutely fascinating behavior. The wasp, as in many parasites which have a particular host, the wasp has a pretty large impact on the numbers of holly blue adults seen each year, so much so that there's a predictable cycle that the holly blue goes in relation to the level of parasitism that occurs due to this parasitoid that we see here. So another example. So working with UK butterflies, we get a lot of images sent to us, and I've had several sent to me along the lines of my caterpillar has just laid some eggs. And of course caterpillars don't lay eggs. So what is it? So what many of you will probably guessing that I might be saying is that someone has seen the yellow cocoons of Cotesia glomerata, which is a well-known well-known parasitoid of the large white butterflies we can see here. A very nice photo from Andy Brown, where the larval grubs have emerged out of the caterpillar and pupated, as we can see here, inside their yellow cocoons. What most people will not have seen is this is shown in this amazing photo by Hans Smid of an adult wasp, female wasp, laying its eggs in a first instar large white caterpillar. An absolutely incredible shot. And as in the previous example of the holly blue, the grubs actually develop inside the caterpillar and ultimately burst out of the caterpillar's skin and pupate, as we can see there. So this is another example of a parasitoid, Trichogramma brassicae, but in this case it doesn't parasitize the larvae of the large white, but the eggs. It's absolutely tiny, as you can see in this amazing photo by Nina Fatoros. So what happens in the large white is when the male and female mate, the male leaves what's known as an anti-aphrodisiac on the female. It's essentially pheromones that alert other males to the fact that the female's already mated, and is really an attempt to deter them from mating with a female again. And this parasitoid actually takes advantage of that. And what they do is the female hitches a ride on the female large white, knowing that she's mated, and basically stays attached to her until the female lands and starts to lay her eggs, after which she hops off and then parasitizes the eggs of the large white itself. And her grubs develop inside the egg, pupate, and ultimately emerge as adult wasps. So again, an incredible phenomenon. This particular parasitoid is also used as a control in some countries. So if you were to Google its name, then you would see that you can actually buy this parasitoid in order to protect things like cabbage crops from the large white butterfly, which is considered a pest in this case. And then finally, just to complete the sad tale of the large white, you'll probably feel, for those allotment growers that don't like seeing the cabbage whites flying around their allotments, they'll probably feel a lot more sympathetic after hearing this story, because not only are the larvae attacked and the eggs attacked, but the pupae are also attacked. So this is a generalist parasitoid, uh, Pteromalus puparum. So again, a very nice picture from Jonas Lutz here. You can see her injecting a large white pupa that's recently formed, using her ovipositor and essentially ejecting eggs into the pupa. Those eggs hatch, the larvae, the grubs develop inside, pupate, and then the adult wasps emerge by making holes in the pupal case and ultimately emerging. So interesting item number 4, defense strategies. So an obvious defense strategy is camouflage, and on the left here you can see some black hairstreak eggs laid on the dark bark of blackthorn, and on the right here you can just about make out a white letter hairstreak caterpillar feeding on an elm flower. The caterpillar itself is in the bottom right, so hopefully you can just make that out as we see here. Another example is the pupa of a black hairstreak. The black hairstreak pupa is shown on the right, but in context on the left-hand side, you can see that it very clearly is designed to mimic a bird dropping. So fascinating to see this kind of camouflage in the wild. Another strategy is remaining out of sight. So here we've got on the left-hand side some small skipper eggs laid in the grass sheath. On the right-hand side, we've got one of the skipper larvae that remains out of sight by creating a grass tube by essentially folding the two sides of the grass blade together using silk bands. So as silk dries, it contracts and it then forms a cylinder that the larva lives within. And in the middle, you can just about make out the profile of a small blue caterpillar in a kidney vetch floret, and you can just about see the entry hole that it's made towards the top of the floret. So remaining out of sight is an obvious defense strategy. And some more examples. So on the left here we've got a red Admiral caterpillar that is created a fairly large construction from a number of nettle leaves that it's living within. And on the right you can see on the top right a Glanville fritillary hibernaculum that it uses to overwinter. So large groups of larvae, since they're gregarious in most of their instars, clustering together inside a very dense silk hibernaculum. So these silk constructions are so dense and compact that they're very difficult to penetrate. And this is demonstrated using the picture in the bottom right here from Andy Butler, which are essentially the waves crashing over this type of construction at Wheeler's Bay on the Isle of Wight. And further examples of remaining out of sight, in this case as a pupa. So on the left side here, we've got a grizzled skipper pupa. So it overwinters as a pupa in a construction, a cocoon made up of a number of leaves of the food plant, in this case wild strawberry. And probably quite unusual in butterflies is the grayling on the right hand side here. It actually pupates under the surface of the soil, which is really a characteristic found in many moths, but quite unusual in terms of butterflies. Another strategy is sight and smell. So by sight, I mean having things like warning coloration. So here we see a final instar swallowtail larva, and it's very contrasting colours, sometimes known as aposematic colouring, is an indication to would-be predators such as birds that it was probably distasteful. Another thing that a final instar swallowtail caterpillar will do is protrude something known as its osmeterium. So this uh, orange fleshy organ that is protruded from just behind the head on the first segment, and it is thought to give off a smell that is similar to rotting pineapple. Now, don't know about you, but I've never smelt rotting pineapple, but it's one of the common phrases used by Victorian entomologists to describe the smell. So that's probably an experiment I'll do at some point, is go down the greengrocer's, get a pineapple, let it rot, and see what it smells like to see if I agree. And a final defense strategy, and this is kind of a bit like remaining out of sight to some degree, but it's feeding nocturnally. So on the left-hand side here is the very hairy meadow brown larva on a grass blade. On the right-hand side, a couple of Duke of Burgundy larvae feeding on a leaf of primrose, with the characteristic feeding damage that they leave there. And during the day, both species will remain very much at the base of the food plant, tucked away, out of sight and out of harm's way. Finally, just like to mention some discoveries that have come about as a result of writing the book. One of these is related to something called larval plasticity. So on the left-hand side, you can see that the glandular fritillary will normally go through 7 instars, but will go through 8 if the larva is underdeveloped during hibernation. So once it re-emerges, it will actually throw out another instar in order to retain, become fully grown. And on the right-hand side, speckled wood, which has got a very interesting combination of criteria. So it will go through 5 instars rather than 4 if A, the larva is female, and B, is developing in cool conditions. So both of those examples have come from research papers that I've read. In the middle, this is something that was discovered by the UK butterflies community, and especially Vince Massimo, who's been studying the Red Admiral in some detail in terms of its immature stages. And what he's discovered is that occasionally the larva will go through 6 rather than the 5 instars that we're familiar with in terms of the Red Admiral caterpillar. So this variation in the number of instars, because it's normally fixed for a given species, is what's known as larval plasticity. So another area where we've made some interesting discoveries is around the timing of the life cycle stages, also known as phenologies, of a couple of species. So on the left-hand side, one of the things I was very fortunate to be able to do was to be able to rear woodwhite and cryptic woodwhite from eggs in exactly the same conditions in my garden, both feeding on meadow vetchling. And to cut a long story short, all of the woodwhites pupated and went into a second brood, and all of the cryptic woodwhites pupated and didn't. And that leads me to believe, at least from that population, from where the eggs came in Southern Ireland, the species is single brooded. And this has been a topic of hot debate within the Irish entomological community. But I think there's some evidence there that potentially the cryptic woodwhite is single brooded, at least in Ireland. And on the right hand side we have Red Admiral, and thanks to the activities coordinated by Vince Massimo on the UK Butterflies website, where he essentially pulls in sightings from various contributors to the website. We now know, as well as his own sightings, of course, we now know that the Red Admiral lays in every month of the year, and he's also discovered that eggs laid in November will hatch in February, so they actually are able to survive essentially the winter months in order to be able to do that. So this butterfly is becoming a true resident of Britain. Another item is the number of larval instars that we attribute to some species. So there are some authorities that say, well, the comma goes through 4 instars in its first brood, 5 instars in the second brood, or vice versa. I really can't remember which. What we've discovered is that through captive rearing, we know that the comma always goes through 5 instars, whether it is the first brood or the second brood. So presumably just some mistake made by the original author that was then replicated in subsequent publications. And on the right hand side, this one is fascinating. So I managed to rear a few mountain ringlets through from eggs. What I discovered was it's quite interesting because Frederick Frohawk, who I mentioned at the start of this presentation, asserted that the mountain ringlet had 4 instars. A lot of the papers I've read says that it has 5 instars, and I am sure that it has 6 instars, and I studied them very, very closely. And I should probably go into more detail at some point as to why I think this, but essentially I believe the mountain ringlet has 6 larval instars. And finally, something that's not in the book, and this is one of the things I'm starting to put a little effort into studying, is the ability to sex a caterpillar. So here are some examples: a purple emperor 5th instar, small white 5th instar, wood white 4th instar, and a large skipper 2nd instar. In all cases, you can just about make out a pair of pale spots towards the rear end of the larva. So let me highlight them there. And it's thought that these are the developing testes of a male butterfly. So if you come across a caterpillar with these pale patches towards their rear end, then chances are you're looking at a male butterfly. Again, of course, this is much harder to see in species which don't have plain green surfaces like this. If they're dark and spiny, then it's probably going to be more difficult to determine. But nonetheless, in these, in certain species, it's quite clear that you can see the developing testes. So, ultimately, I find this study of immature stages absolutely fascinating. So fascinating that I was compelled to write the life cycles of British and Irish butterflies. And thanks to everyone that's provided the feedback. It's been absolutely amazing. It's nice to know that the book's been enjoyed and appreciated by so many, and hopefully will be put to good use. And I really shouldn't finish up without thanking a whole bunch of people. They're all listed here. But the 2 people I should really highlight, first of all, Mark Colvin. We spent many hours in the field together on various studies, and there's a picture of Mark helping me at his own expense looking for final instar post-hibernation checkered skipper larvae at Glasdrum Wood in Scotland. And in the bottom right, Vince Massimo, who I've already name dropped several times, but he's been quite an inspiration in terms of his own studies of immature stages and has posted his findings on the UK Butterflies website. So thanks to everyone that's mentioned here, the reviewers, additional help that's been provided, and the photographers, of course, that have provided images for the book. And again, I hope you find this useful, and again, a respite from the current lockdown that we're in. I'll probably think of some other subjects that I can present on, but again, do let me know if this is appreciated, and I'll no doubt produce some more. So thanks for watching, and enjoy the rest of the day.